Hello, our objective today is to use and interpret function notation. So function notation you have seen is when you say f of x equals some function. And there's two ways that you could use this. The first way in example A is to say f of negative 1. Now you notice if the function is f of x, then this means that the x is being replaced by negative 1. So in the actual equation, we will take every place you see an x and we will put a negative 1 in there. So I'm writing negative 2 parentheses negative 1 squared plus parentheses negative 1 and then minus 5. We now just simplify this using order of operations. Negative 1 squared is 1, so this is negative 2 minus 1 minus 5. So we finish off by saying that f of negative 1 is equal to negative 8. What we just found is called a function value. The function equals this at negative 1. So this is a function value. Part B is the same idea, although we're now plugging in x minus 4 where the x is. So I'm going to write equals negative 2 parentheses x minus 4 squared plus parentheses x minus 4 and then minus 5. Now we've got some simplifying to do here. So when you square out x minus 4 squared, you get negative 2 times x squared minus 8x plus 16. You can show more steps for that if you want, but if you don't have to, then don't. And then we still have the plus parentheses x minus 4, and we still have the minus 5. I'm now going to distribute that negative 2, so I have negative 2x squared plus 16x minus 32, and then there's nothing to distribute here, so I'm just going to write plus x minus 4, and then we still have the minus 5. Finally, we're going to combine all our like terms. You notice we have x squareds, x's, and constants. So our final answer here is going to be negative 2x squared plus 17x when you combine 16x and x. And then minus 32 minus 4 minus 5 comes out to minus 41. So our function value here when we found f of x minus 4 is this, negative 2x squared plus 17x minus 41. The next type of problem is actually a little bit different. You notice it doesn't say f of negative 5. It says the function equals negative 5. Well, notice the function here is that. F of x equals this. So I'm just going to plug all that in onto the left side of the equation, and it's going to equal negative 5. So I'm going to write negative 2x squared plus x minus 5 equals negative 5. We can now solve this. So I want to get it to equal 0 because it's quadratic. I'll add 5 on both sides. And you notice that we get negative 2x squared plus x equals 0. This is factorable because the GCF is x. So when you take out an x, we have negative 2x plus 1 equals 0. Sorry about the lack of space here, but we are at the zero product property step. So we have x equals 0. That's one of the factors. And then we have negative 2x plus 1 equals 0. So our answers here, there's two of them. The first one is 0. We had already found that. And the second one, again, sorry about the lack of space, but you have to subtract 1 on both sides and then divide by negative 2. So negative 1 divided by negative 2 is positive 1/2. So that is our other x value. That gives us a function value of negative 5. I don't have space for it here, but if you plug 0 in to this function, you'll get negative 5. And if you plug 1/2 into this function, you will get negative 5. Our final type of problem here is what we're going to have as an application level problem, and that's when you have function values in the middle of a wider function. So what we're going to do here is this. You notice we've got this whole thing going on, but you see an f of 4 and an f of 0. So we already know how to plug stuff in. So first I'm going to find f of 4, and I do that by doing negative 2 times 4 squared plus 4 minus 5. And let's see, this is this is 16 times negative 2, which is negative 32, plus 4 is negative 28, and then minus 5 is negative 33. And then I will also do this with f of 0, and that one's a little bit easier to do in my head because it's negative 2 times 0 squared, that's going to be 0, plus 0, which is 0, and then minus 5, which is all negative 5. And now once I know these values, I can plug them in here. So notice it says 2 times f of 4 minus 7 times f of 0. Well, I'm going to color code this a little. You see how f of 4 equals negative 33? Well, that means right here where there's an f of 4, I'm going to put in a negative 33. And you also see that f of 0 equals negative 5. So right here where there was an f of 0, I'm going to put a negative 5. So we are almost done with this. We're just going to simplify using order of operations. 2 times negative 33 is negative 66. And negative 7 times negative 5 is positive 35. And negative 66 plus 35 is negative 31. So all of this expression came out to negative 31. So that is it. We have used and interpreted function notation both by finding function values and using function values to find x values.